Section 4.6, we're going to talk about graphs of the other trigonometric functions. So remember in 4.5, we talked about sine and cosine. And so in 4.6, we have the tangent, the cotangent, the secant, and the cosecant all left to talk about. So we're going to look at the graphs of the tangent and cotangent functions, and then also the graphs of the secant and cosecant functions. So just a few things. Tangent function is odd. Okay, and when we look at the graph of the tangent, remember an odd function, it has that rotation symmetry about the origin. And so that formal definition is if you have the tangent of negative x, it would equal the negative tangent of x. And this right here, you can actually find that on your formula sheet as well. So that's not something that you need to have memorized. Also remember on your formula sheet is that the tangent is sine over cosine. So what that means is that since we have the sine of x over the cosine of x, when the cosine of x is 0, our tangent function will be undefined and we'll actually have vertical asymptotes. So when we think about our unit circle, our cosine is 0 at pi over 2 and negative pi over 2. And so that's where your tangent will have the vertical asymptotes. Just a table of values here as we look at our y values. So at 0, 0, your tangent goes through the origin. And then at pi over 4, your tangent's 1. And at 1.5, it's 14. And at 1.57, it's 1,255.8. And then at pi over 2, it's undefined. So it's that idea that it's growing and getting really big as it approaches that vertical asymptote. And then in the other direction, it's getting really, really small. So it's going towards negative infinity. So this is your tangent graph. This is what it looks like. Remember, we talked about that it has that point at 0, 0. And then it also has zeros at all of the whole pi's. So it goes through 0, it goes through 1 pi, it would go through 2 pi, negative pi, negative 2 pi. It has the vertical asymptotes at the pi over 2, so at the odd pi over 2. So at pi over 2, at 3 pi over 2, right, at negative pi over 2, we have the vertical asymptotes. And when you're sketching this, you need to sketch those vertical asymptotes. And then your tangent graph increases. Something to remember is that it increases from left to right. And so then this table over here kind of gives you all of that information. The domain is all real numbers as long as we're not talking about the asymptotes. So those are your pi over 2 plus pi n, where n is an integer. The range is negative infinity to infinity. It goes up to positive and down to negative. Period of your tangent, keep in mind period of tangent and cotangent is pi. If we look at this graph, if you notice the length of time it goes through one of these cycles, if we went from negative pi over 2 to pi over 2 or pi over 2 to 3 pi over 2, that length of your cycle is pi. So the period of your tangent is pi. Same thing with cotangent. But remember, sine and cosine was 2 pi, so those are different. Your x-intercepts are at all the whole pi's. Your y-intercept is at the origin. We have our vertical asymptote. It's an odd function, and it has that symmetry around the origin. All right, so because the period of tangent is pi, the vertical asymptotes, again, occur every pi after that first one that we think about at pi over 2. So you just count over pi, and that's where the next one is going to be. All right, so let's sketch this graph. But we have to look at this. If we have y equals the tangent, and instead of saying x over 2, I'm going to rewrite this as 1/2 x. So remember back to the sine and the cosine, that number in front of your x was your b value. And the tangent still has those same values, but because the period of tangent is normally pi, when we have to figure out the period of these tangent and cotangents, if they've been compressed or stretched, the period will be pi over b instead of 2 pi over b like it was in sine and cosine. So in this case, our b value for this one is 1/2. And so if we calculate the period for this tangent is pi over 1/2, which gives us 2 pi. Okay. So when we draw our tangent graph, normally the period is pi, right? So normally we would say that second dash mark is pi, but now we're going to say that the second dash mark is 2 pi, and that middle one is pi. So kind of like we did with sine and cosine, okay? And so what happens is normally in our tangent, on our kind of our original one, I'll sketch it over here real quick. In our original one, that one was pi, and then that first one, if we just split it, was our pi over 2 and our negative pi over 2, right? And then at the pi over 2's for tangent, that's where we had the vertical asymptotes, right? And then our tangent graph increased. It went through 0, 0, and it increased, okay? So here where the period is 2 pi, it's really similar, but now instead of our asymptotes being at pi over 2, they're going to be at pi because we're multiplying our x value by 2. So now these vertical asymptotes are at pi, and our tangent graph goes through 0, 0, but then it's stretched horizontally by 2, so instead of crossing at pi, now it crosses at the 2 pi's, but it still increases, right? So it would still be increasing as it goes through that x-intercept, right? So here we drew 3 cycles of the tangent. And then this is a picture that the book gives of what that looks like. Theirs is a little bit neater, not quite as colorful though. So then the next thing we're going to talk about is the graph of cotangent. And remember, cotangent is cosine over sine. So with tangent, our vertical asymptotes were when the denominator equals 0. So here we'll have when sine equals 0, and sine equals 0 at 0 and pi and 2 pi. So for cotangent, you'll have vertical asymptotes on the x-axis at 0, pi, 2 pi, right? And we'll keep going in both directions. And so then if you look at this graph, you notice that those vertical asymptotes are at the whole pi's, right? So negative pi, positive 2 pi, right? And then it equals 0 this time at the pi over 2's. Oh, we should have a vertical asymptote here at 0 as well. Okay. And then the other thing with the cotangent is that the cotangent decreases. So decreases from left to right. Okay, so the big difference is their asymptotes, in a way, it's like cotangent asymptotes shift over to where the tangent was crossing the axis, and now that's where the cotangent is undefined. And then it's a decreasing function. But in terms of their domain, it's all real numbers except for where those vertical asymptotes are. The range is still negative pi to pi. The period for cotangent is still pi. And then you have your x-intercepts at the pi over 2's plus pi n. Vertical asymptotes are at the pi n's. It's still odd, and there's still that origin symmetry for it. So if we want to graph this example 3, sorry about the slides skipping around there. We have to look at this, and there's a couple things. First, we have the 2 out in front, and that's something kind of important we need to talk about, because you would think that it would mean, well, the cotangent has an amplitude of 2, But because the range for tangent and cotangent is negative infinity to infinity, there is no amplitude. So you wouldn't ever say that there's an amplitude for tangent and cotangent. So that 2 will just stretch it a little bit vertically by 2, which just means it just stretches it a little bit longer, but we don't do a whole lot with that in the graphs. And then here, again, if we rewrite it like we did for tangent to 1/3 x, right, we know that the b value is 1/3, which means that the period would be 2 pi, not 2 pi, because it's tangent, so it's just pi over 1/3, which would be 3 pi. Okay, so everything is going to be stretched by 3. So when we draw this cotangent graph, I'm again going to draw my increments, my 3 pi, and then that halfway, and my negative 3 pi, and the halfway. And remember, your cotangent had asymptotes at the y-axis, so it has an asymptote here. And then it normally had an asymptote at pi, but that got stretched all the way out by 3, so now that one went out to 3 pi and negative 3 pi, right? Because the period was normally pi, but now it's 3 pi, so it's stretched horizontally by 3. And so then once you have the asymptotes in there, then you just fit that cotangent graph in between those. So your x-intercepts will be at 3 pi over 2. And then remember, your cotangent decreases. So your cotangent starts high and it decreases low. So make sure when you're graphing these, you are graphing those vertical asymptotes, and then you're fitting the graph in between those asymptotes. And so when we look at the solution slide for this, it just shows that graph, and on this one it shows actually coming up with some x and y values that you could put on your graph. I'm okay if we don't do that and you really just put those vertical asymptotes in there and the x-intercepts in there, and then you'll be good to go. So the other two graphs we have are secant and cosecant. And remember that cosecant is the reciprocal of sine, and that secant is the reciprocal of cosine. And so when you're graphing secant and cosecant, it's really helpful to first just do a rough sketch of what the sine and cosine graphs would look like. And then we fit the secant and cosecant graphs into those. And I'll show you what I mean there. So this talks about the asymptotes again. Remember, secant is 1 over cosine. So secant will have the vertical asymptotes when cosine is 0, which are the same as the tangent. So they're at your pi over 2s. And then your cotangent and your cosecant have the vertical asymptotes when your sine is 0, which is at your whole pi values, your pi n's. So to sketch your secant or cosecant, you first should make the sketch of its reciprocal function. So if you're sketching cosecant, we first would sketch sine. And if you're sketching secant, you would first sketch cosine. All right, so here's our graphs, and there's a lot going on here, so we'll work on some of these. But what I want you to notice is that with the secant graph, if you were to first sketch this sine graph, right? So this is your sine graph right here. And if you first sketch this, where sine equals 0, because cosecant is 1 over sine, right? This is 1 over sine. So where sine equals 0 is where your cosecant has those vertical asymptotes. So when you sketch that sine graph, then it makes it easy to see where those vertical asymptotes are going to fall, because it's wherever your sine graph would be 0. All right, so you can draw those vertical asymptotes in. And then what happens with your graph is you've got the sine, and then your cosecant graph just fits in there. So your cosecant graph are these u's. They come up, they touch the sine graph, and they go back down, and they just fit right in there in between those vertical asymptotes. So then you have the one on the top that touches, and it goes back up, and then it touches, and it goes back down. So because you're more familiar with sine and cosine, it makes it a lot easier if you draw those first. Okay, and then secant is that same thing, but with secant, you're graphing that cosine graph first. So when I graph these, I usually graph those with a dotted line, right? And then wherever that equals 0, those are the places where you would have your vertical asymptotes. And then that last step is just fitting those values in there. And remember, it only touches right here and then it goes back up. They don't overlap. So your secant and your cosecant don't actually go up and touch that x-axis. They just touch where that sine and that cosine graph are. And then we have all of that information for your secant and your cosecant graphs. All right, so we are going to work on sketching the graph of 2 cosecant times x plus pi over 4 by hand. And so when we sketch this, we are first going to think about sketching the graph of y equals 2 times the sine of x plus pi over 4. So that's the graph we're graphing first, and then we will fit the cosecant in. So when we're looking at this sine graph, right, we know that we're going to have an amplitude of 2. Our b value is 1, so the period is 2 pi. And then the phase shift is your c, right? That's our c over our b. And because b is 1, our phase shift is just going to be pi over 4 to the left, right? Because it says plus pi over 4, which means it's actually moving to the left. All right, so let's draw our sine graph. If the period is 2 pi, negative 2 pi. All right, so our amplitude is 2. So we'll go up to 2 and down to negative 2. And then we're shifting it to the left pi over 4. So we have to think about where pi over 4 is to the left. So this is negative pi, which would mean this is negative pi over 2. So everything is shifting to the left, and I'm going to make my axis yellow, pi over 4. So this is like our negative pi over 4. So this y-axis is shifting right here. So that's like our new y-axis. That's like our new origin, right? So this point right here is like the new origin. So we shifted it over. And so now everything is kind of shifted that half stuff over. So when we graph this sine graph, and I'll graph the sine graph in purple. So this is our just kind of our graph that we're using to fit. So our first point is at the origin, right? And then our second point normally goes up to 2, right? And that's at this first dash mark here. But remember, it got shifted over pi over 4, so it's actually halfway in between. So now all of our points are going to be halfway in between our dash marks because they all got bumped over to the left. And then it's going to go back here. I'm going to change this one back here into black so we're not confused with that point. And then the next one will go down to negative 2 when we're halfway in between. And then we'll go back to the origin. And then same thing here, we'll go down to negative 2, back to the axis, up to positive 2, right? And then because this isn't really even the graph that we need to be drawing for the problem, because the problem wanted cosecant, I just draw a dotted line. So this is like my guide. All right. So then our next step is to look to see where does this equal 0? And you're really looking for where it's changing, like from opening down to opening up. That's where those zeros are. So we're talking about all these points right here along the x-axis. That's where it equals 0. So we're going to draw our vertical asymptotes. You always have to draw your vertical asymptotes in, because that tells you how wide your graph needs to be. Mine aren't real straight, but that's all right. Do your best effort. Okay. And so now in between those vertical asymptotes is where we are going to fit our cosecant graph. So our cosecant graph, remember, comes down, it touches, and it goes back up. And then down here, it would come up, it would touch, and it would go back down. And it just fits in between those asymptotes. So it would touch, and it would go back up, and then it's going to touch, and it's going to go back down. And so the key to drawing these, I think, is really to draw those reciprocal functions first for secant and cosecant. And so when you look at the solution slide, this gives you a little bit cleaner look than the one that we drew. But again, if you notice, they're at negative 2 pi. So this would be their negative pi. This would be negative pi over 2. So right here is where everything shifted over to, just like we had. Also, that gray line is your sine, and then that cosecant graph fits into there.